Okay, so we're going to go through the second part of the lesson 1 notes. So Mendel's flower crossing experiment was an example of a test cross. I don't know why I wrote that so weird, but I did. But it was an example of a test cross. There should be no space here. I'll just actually fix it, or else it'll bug me. So it was an example of a test cross. Now this is used when you're trying to determine the genotype of an organism. So Mendel, in his case, he used a true purple and a true white. So this means this one was homozygous dominant, and this one was homozygous recessive. Remember, homozygous means the same. So two the same alleles. Two the same alleles, two the same alleles. So now the gametes for these would be, so I'm going to separate these. So it's going to be parent 1. This is going to be parent 1, and this will be parent 2. So the gametes for parent 1 are going to be P and P. So that's parent 1. Big P and big P. Gametes for parent 2 will be little p and little p. So that's parent 2. And I put a line underneath these when I draw them because p's look the same and I draw my p's all the same size. So just to help me not confuse the lowercase letter with the uppercase letter. So that's a big P, little p, little p. So these are the gametes, right? Gamete 1, gamete 2 for parent 1, gamete 1, gamete 2 for parent 2. Now, you remember why this, if just some background so this makes sense, is during meiosis, right? We're doing a pea plant, but this is going to be basic, right? You get original cell, you have your cell originally, right? It's going to have its chromosome, right? Chromosomes that attach, this pair of chromosomes, right? On one of these chromosomes, you are going to have the parental, right? So you're going to have the big P. So this is for parent 1, you have big P, and the other one, you have big P. So here's your chromosomes, and here are your two alleles, right? One allele on this chromosome, one allele on this chromosome. Now, when meiosis happens, and you get those 4 gametes, they're split in the chromosomes are split up, and now these gametes are haploid, which means they have half the number of original chromosomes. Well, when that happens, these alleles get split up. So that's where these gametes come in. So each one of these will have half the number of chromosomes, and since, in this case, since this is a true purple and both of these alleles had a big P, all these chromosomes are going to have the allele for P that code for the purple flower. Now this cross is what we're representing is when fertilization happens. So I always put parent 1 on the side just to make things easy. So parent 1, big P, big P. Parent 2 here. And remember, these are the gametes for parent 1. These are the gametes for parent 2. I know I'm repeating myself a lot, but I just really want this to stick in your head. So now we're going to model fertilization. So that's when these chromosomes come together with or these gametes come together with the gametes from another pea plant, and then fertilization happens and these chromosomes come back together. So I'm going to use just the same color for each one of these. So this one, right, we have big P, big P, big P, big P, big P. So it's for all these, right here. Now when fertilization happens, little p, because remember, there's 4 gametes for this parent too, except all these ones have the little p. Now coming together and formation happening. So once that fertilization happens, we now have our plant. This is going to represent 1, right? Fertilization happens. We have our chromosomes. Now one of those chromosomes has the little p, and one of those chromosomes has the big P. So this is our offspring. So all these offspring are heterozygous, which means different alleles. And by different, it just means whether it codes for a dominant or recessive trait. So this one codes for purple, and this one codes for white. So inside the Punnett square is all the possible genotypes of the F1 generation. So all possible genotypes of the F1 generation. Okay, so all these genotypes are big P, little p. So that's all the possible genotypes. Now all the possible phenotypes. Now this is the physical characteristic, right? So genotype is the letter combination. This letter combination is big P, little p. Now the phenotype is a physical characteristic. So this genotype would produce a purple flower, right? So all these offspring are going to be purple. So now we're doing the hybrid. So for these ones, right, I'm just going to, for hybrid, for parent 1, it's going to be big P, little p, right? For number 2, same thing, big P, little p. So that means the gametes for parent 1 will be big P, little p. And the gametes for parent 2 are going to be big P, little p. So now I do the same thing. I fill in that Punnett square. So one gamete goes here, another gamete goes here. Alright, so that's little. Other parent, gamete, capital P, other gamete, lowercase p. So I'll do all these ones first. So this will be big P, little p, big P, little p. Now I'm just going to erase this for a second. These two, just so you know, I'm going to give myself more room to the right. You'll see why in a second. So little p, little p, little p, little p right there. So now we're doing blue. So this is big P, little p, big P, and big P. So I erase those because I like to always put the dominant trait in front. It just looks better, and that's the accepted way to write the genotype down. So now if you look at this, you can tell this one got an allele from one parent, which was dominant, and the other allele, which is dominant. So in that case, this one is homozygous dominant, right? This one down here should be a little p, right? So this one down here, homozygous recessive. This one's homozygous recessive. See, recessive, homozygous recessive. These two are heterozygous, right? 2 different alleles. One dominant, one recessive. One dominant, one recessive. So this plant has it's a 3-to-1 ratio, right? So all for phenotype. So all 3 of these are going to produce purple flowers. This one will produce white flowers. So the possible genotypes for this plant. Possible genotypes are capital P, capital P, capital P, little p, and little p, little p. All possible genotypes. Possible phenotypes is equal to purple or white. So that's how you fill out these Punnett squares. So now, when is a test cross used? Well, it's used to determine an unknown genotype. And what is the ideal genotype to use when conducting a test cross? Well, the ideal genotype to use is homozygous recessive. So homozygous recessive is the ideal genotype. And why is that? Because if it's white and it's homozygous recessive, you already know the genotype, right? 2 little p's. Now, if it was dominant, it could either be homozygous dominant with 2 capital P's or heterozygous with a capital P, lowercase p. So when you cross it and you don't know the parent genotype and you get your offspring, you're not going to get any data you can read. But with this one, you can. And that's what will be one of my other videos on. We'll show the importance of a test cross. Thanks for your time.